In section 1.1, we want to get familiar with some terminology of the trigonometry. We, and the first and terms that we want to get familiar with is our angles. What are angles? How do we form an angle? Before we talk about angles, we want to know what's a ray. Ray is a part of a line that has only one endpoint and extend forever in another direction. So in one side, we have an endpoint, and the other side, it goes forever. Now, if we have two rays that they have a common endpoint, we can form an angle between the two rays. So as you see in the picture, the ray A uh, has endpoint and point B, and ray BC has endpoint and point B. So the two rays have a common endpoint. So they form an angle, angle theta. And one of these rays always called the initial side, and the other side is called the terminal side. And the common endpoint of the two rays is called the vertex for that angle. Now, how we can graph an angle in a standard position. In trigonometry, for graphing an angle, we always have the vertex of that angle and the origin of the coordinate plane, and the initial side of the angle along the positive side of the x-axis. So all the angles in trigonometry class are in this form. They are in the standard position, which means the vertex must be in the origin of the coordinate plane, and the initial side must lie along the positive x-axis. We can have terminal side in any other quadrant, and we can form angles in any direction. We can go counterclockwise, or we can find an angle which is clockwise. So what's the difference between the counterclockwise and the clockwise angle? If you have an angle which is formed from initial side to terminal side in counterclockwise rotation, it means you have a positive angle. But if you have an angle which is formed in clockwise direction between the initial side and the terminal side, that means you have a negative angle. So all of the positive angles are in counterclockwise direction, and all of the negative angles are in the clockwise direction. What's a quadrantal angle? Quadrantal angles are the angles which the terminal side overlies in the x-axis or the y-axis. So you know that in trigonometry, all of the initial sides are on the positive side of the x-axis. Now, where is the terminal side? In quadrantal angle, the terminal side is always along the y-axis or the x-axis, like this angle. Or if the terminal side is here, we have this angle. If the terminal side is this side, on this side, we have this angle. And you can see all different forms of angles, the quadrantal angles. If the terminal side is exactly on the positive side of the x-axis, it's exactly on top of the initial side, we have a 0-degree angle. But if the terminal side is on the positive side of the y-axis, we have a 90-degree angle. If the terminal side is along the negative side of the x-axis, we will have a 180-degree angle. And if the terminal side is along the negative side of the y-axis, we will have a 270-degree angle. We can have another angle, which you know the initial side is always on the positive side of x-axis, but if the terminal side also is on the positive side of the x-axis, we will have a 0-degree angle, or we may have a 360-degree angle, which is a full rotation. So to measure angles, we have two different measurements. One measurement is called degree, and the other measurement is called the radian. So we are familiar with degree, and you know, in any circle, a full rotation is 360 degrees. Now, if we have an angle which the terminal side is on the first quadrant, like this angle. So you will have an angle which is less than 90-degree angle, and all the angles that are less than 90-degree angle are called acute angle. If the terminal side is exactly along the y-axis, you will have a 90-degree angle which is called right angle. If the terminal side is on the second quadrant, you will have an angle which is more than 90 degree but less than 180 degree angle. And these angles are called obtuse angles. And if the terminal side is exactly on the negative side of the x-axis, we will form a 180 degree angle, which is called the straight angle. Another form of measurement is called the radian. Radian is another measurement for angles. For radians, what we need is the length of the arc that intercepted by that angle. If we have a circle which the vertex of the angle is exactly on the origin or on the center of the circle, and initial side is and the terminal sides are the radius of the angle, we can say that this angle is a central angle. And this central angle theta, as you see in the picture, intercepted an arc, and the length of this arc, which is S, is measured. Now, to find the radian measure of this angle, we need to divide the length of the arc, the length of the intercepted arc, divided by the radius of the angle, radius of the circle. So to find the radian measure, we need the length of the arc and then divided by the radius of the circle. So as you see, for showing degree, we have this small O on top of the number we can show for the degree, but for radian, we don't have any notation, so we just have to write radians next to the number that we get as a radian measure. So let's look at an example. Example 1, it says a central angle theta in a circle of radius 12. So we have a circle. The radius is 12. And we have an angle theta which intercepts an arc of length 42. Think that this is our angle theta, and the intercepted arc, or the length of this arc is 42. So the length of the arc is S, the radius is R. We want to find the radian measure of theta. So to find the radian measure, we just need to divide S by R, divide the length of the arc by the radius of the circle. And if we divide 42 feet by 12 feet, we get 3.5. And 3.5 is the radian measure of theta. So we can say theta is 3.5 radians. Let's look at another example. We have another central angle. Central angle, theta. And the radius of the circle is 10. And the arc that intercepted by this angle, the length of the arc, which is this part, is 40. What's the radian measure of data? Again, we have S, the arc length, and we have 10, which is the radius, divide 40 by 10, and we get 4. So we can say that the radian measure of data is 4. Now the question is how we can convert the measure. If you have a radian measure, how we can convert it to degree? Or if you have a degree, how we can convert it to radian? So all we do is just multiplying by a fraction, and that fraction is pi over 180 or 180 divided by pi. Because you know in any circle, this is pi. This point is the pi. And that's exactly half of the circle, which means it's 180 degree. Because the full rotation is 360, so the half of it is 180. So 180, that's exactly the same as pi. Pi is in the radian form and 180 is in degree form. So if you have a degree and you want to convert it to radian, just multiply that number by pi over 180. But if you have a radian and you want to convert it to degree, since you don't want any pi, so you multiply by 180 divide by pi because you want to cancel pi. And you just have a number as a degree measurement of the angle. If you look at this example, we have a degree measurement, we have a 60 degree, and we want to convert it to radian. So just multiply by pi over 180. And if you multiply by pi over 180, you can, and you know that when you multiply two fractions, you always multiply the top by top and the denominator by the denominator. So 60 times pi on the top and 1 times 180 at the bottom of the fraction. Now, can we cancel out? Yes, we can simplify 60 by 180. So we get, if you divide both by 60, we get pi over 3. So 60 degree, that's exactly the same as pi over 3 radians. In degree is 60, in radians is pi over 3. The next example is 270 degree. That's a degree, we want to convert it to radian. It means we need to multiply by pi over 180. And you know that the pi is radian. So again, multiply the top by top and the bottom by bottom. So it's 270 pi divided by 180. We can cancel 1 zeros and the degrees. So we will have 27 pi over 18. Can we cancel? Yes, we can divide both numerator and denominator by 9. And if we divide them by 9, we get 3 pi over 2. So we have 3 pi over 2 radians. Next example, we have a negative 300 degree. We want to convert it to radian. Again, we multiply by pi over 180. We can cancel zeros, 1 zeros out of each number. So we will have negative 30 pi and divided by 18. This time, we can simplify 30 and 18 by dividing by 6. If we divide both by 6, we get negative 5 pi over 3. And that's the radian measurement of negative 300. Now in our next example, we have radians. We want to convert them in degree, to degree. So the first example is pi over 4 radians. How we can convert it to degree? By multiplying by 180 divided by pi. Now when you multiply, you can cancel pi by pi and you just divide 180 by 4, which gives you 45 degree. And this is the notation that we use for showing degree. You don't need to write degree because there is a notation to show the degree. And next example, we have negative 4 pi over 3 radians. We want to convert it to degree. How? By multiplying 180 over pi. And if you multiply the numerators and the denominators, you get negative 4 pi times 180 on top and 3 pi for the denominator. You can cancel pi and pi, You can simplify 3 by 180, and you can multiply the numerators. Negative 4 times 60 is negative 240. So it's negative 240 degrees. And the next example is 6 radians. 6 radians, we want to convert it to degree by multiplying by 180 over pi. Okay, multiply the numerators and the denominators. So we'll have 6 times 180 on top and pi at the bottom. But when we change to degree, that means we don't expect to have any pi. We just need a number. But as you see here in this example, the pi didn't cancel out. So what we can do, you can replace the pi by 3.14 or the whole number, or you can use the pi key on your calculator. So what do? We multiply the 6 by 180 and then divide it by pi. There is a pi key on the calculator, and if you divide 1080 by pi, you get 343.77 degrees. If you do it manually and replace the pi by 3.14 only, your decimal part of the number may be a little different, but if you use the pi key on the calculator, you should get the exact value.